Welcome to Master of Science with host Professor James McCanney. The good professor's career spans 50 years as a university teacher, scientist, and engineer. Each week, he will explore the rapidly changing world of science as many long-held theories are crumbling under the weight of new data. He will cover the fields of geology, archaeology, meteorology, oceanography, space science, astronomy, cosmology, biological evolution, virology, energy, mathematics, and more. So please welcome the host of Master of Science, James McCanney.
And good evening again. Very nice to be here, very happy. But, every week I don't do this every week, but most weeks I want to talk about the conditions in the scientific world, educate you as to the fabulously bizarre world of science and scientific theory, and how they're still resting on theories, in standard, especially astronomy, astrophysics, that were developed in some cases hundreds of years ago, long before the space program and long before anybody knew anything about outer space. In fact, they weren't really sure how far the atmosphere went. We're talking about the Middle Ages, where Kepler, the guy who was instrumental in giving us understanding of things being not in the atmosphere like Aristotle talked about, but out there, out in outer space. He knew that comets were out there. I think they had a good idea that the Earth's atmosphere ended, but they had no clue where it would have been, and that comets were out there. And he speculated this is where this comes from. He worked with Edmund Halley. Remember Halley was able to understand that the comet that's named after him came back every 70-some years. It was periodic, and they went back to old, prior Middle Ages, like the tapestry that had the picture of the comet. What was it? I forget, in the early thousands, and they were able to trace it back all the way back to the Chinese. And so they looked out and they said, well, these comets are out there, and they get close to the sun and they form this tail. So the logical conclusion, 15th century logical conclusion, certainly not today by any stretch of the imagination, the idea was that these objects would be made of ice. Excuse me, I think I'm losing my voice here. I hope I get through this show okay. But anyway, excuse me. Pardon me. Okay, so the idea was that these objects that had ice in them would get close to the sun, and of course that makes sense, 15th century, and that the sun heats it up and these tails point away from the sun, all made a lot of sense in the 15th century. But today they're still pounding the pavement with that same concept. And now let me put this into perspective. We have visited with space satellites probably around 10 comets now, the nuclei of about 10 comets. So we have up close and personal pictures of them. They're hot, dry rocks. There's not an ounce of snow or ice or anything on them. So where does the tail come from? Well, that I found out in my work. In fact, this poster I had up last week, and I got so many great comments on it that I'm leaving it up again this week. But behind me, I have some photographs of comets. And in fact, over in this side, this photo here, last week I talked about the comets that are forming out in these outer regions, which would be then in the equivalent of our own solar system, what are known as the Kuiper belts, where there are thousands of planets forming, and these are forming because of the discharge of the solar capacitor, which is building up. These comets are building up material and growing. And Pluto is one of them. I'll be talking about Pluto tonight, but just to give you a prelude of my topics tonight, I will be talking about fire. This is in outer space, fire and ice and diamonds. So if you want to become fabulously wealthy by Earth standards, then back in the old pirate days, you would go out and sack a ship full of gold or something like that, and that was every pirate's dream. Well, you can do that today, and there's nobody sitting out there with cannons trying to stop you, but there's vast amounts of wealth to be had in outer space. Minerals and diamonds, big diamonds like you've never seen before. I'll be talking about how those form and how the idea, see, all these standard science ideas are just so lame. There again, but anyway, let me finish the thought about comets, that we have actually landed a spacecraft on the nucleus of a comet. There is no snow, no ice, no water, nothing coming off of the nucleus at all. The water you see in the tail is coming in towards the comet nucleus, and what happens is the hydrogen and oxygen are abundant in outer space. Hydrogen is the most abundant element in the universe, and our solar system has a great deal of it in free form out in the solar system. And when a comet comes through, it's picking that up, it's pulling it in, and read my books that talk about the theoretical model. It's called the plasma discharge comet model. And when the hydrogen and oxygen meet, they give off energy. That's why they use it for the fuel in the space shuttle, and then the most chemical rockets today are using oxygen and hydrogen. And so, at any rate, back to the idea of diamonds. I'll be talking about diamonds forming on the nose side of comets in this plasma discharge. And it's very similar to the operation in the laboratory, where you can create diamonds with an electric field, a stream of electrons, and a vacuum. And some carbon, throw in a little bit of carbon there. And I'll be talking about some of the other really ridiculous ideas that ice balls have come into the atmosphere, exploded, and created diamonds. Now you have water hitting water. That's the concept, that this ice ball comet hit Greenland, and which is capped with ice, so H2O hitting H2O, and somehow you get diamonds. Well, gee, boys and girls, where did the carbon come from? Because diamonds are pure carbon in its purest crystalline form. That's what diamonds are. And so anyway, so ice hitting ice, water ice hitting water ice, creating diamonds, good luck. Once again, standard science is promoting this idea that somehow ice hitting ice creates diamonds. Absolutely. I mean, a third grader wouldn't buy that, and it's being promulgated in the scientific community. But what I want to talk about tonight is, first of all, when I do this show, somebody's listening. And of course, you, the audience, you're the people that want to learn. But there's a lot of people, of course, that follow what I'm doing and want to give disinformation. So they want to squelch the ideas that I'm putting out here. So interestingly enough, after I think it was the second lecture in this series, I talked about the Nazca lines. And so anyway, the news media the next day after that show was filled with stories about the Nazca lines, and all the experts, all the archaeological experts, thought they were paths for prayer or the landing strips for aliens, or oh my goodness, it went on. And of course, they couldn't figure out what these magical lines were for. And I spelled it out clearly so once again, a third grader could understand it. And that's, by the way, the power of my lectures and my TV series is that, you, the public, a lot of times are swindled by PhDs and people with degrees, and, they sit on their chair, their lofty chair, spewing their scientific theories, whatever, that are in peer-reviewed journals. But the problem is that they're usually complying with things, like I say, like with Kepler, hundreds of years old concepts, and they're still locked onto these. And that's the unfortunate thing. But the way I explain things you can understand. You don't need a PhD to understand what I'm talking about. I explain it and give examples, etc. So, but then the reason I'm talking about the Nazca lines and the disinformation that came out the next day is it happened last week again. When I gave my lecture about the Tunguska event, by the way, when I was working with these Russian scientists from the University of Novosibirsk in the mid-1990s, they were the scientists that went from Russia to the site at Tunguska, one of the teams that went out there and studied this site with nose to the ground. So they looked for everything, every possible explanation, and they came back bewildered because there's not a trace of evidence of an explosion there other than the forest is simply flattened in all directions. And the explosion was very close to the ground when the explosion hit, because in this little circle at the center, at the epicenter, if you look at the trees, they're blown outwards from that spot. And if the explosion would have been very high, then the trees at the center would have just, the rush of air would have come down, but it wouldn't have blown them outwards. So the explosion, this is one thing we absolutely know, the explosion was very close to the ground. Ground zero, literally, maybe a half a mile high at most, maybe less, but probably quite a bit less than a half a mile high. And interestingly enough, I had this in a note in one of my slides last week, the calculated power or energy in that explosion was estimated to be about 200 times the bomb that was dropped on Hiroshima, the atomic bomb. So we have something that is 200 times the amount of energy being expended in the low atmosphere, 200 times that of a nuclear bomb. And somebody's trying to tell you that a little boloid of ice came in and melted and exploded and burned all these trees, just, scorched them. And they're still, many of them are still there today because it's up in the tundra, and the parched wood just has been sitting there, in a very short summertime, very short time for them to decay and rot. And so it's only, what was that, in the early 1900s. Okay. But anyway, my point is that last week after my show, lo and behold, now where this disinformation comes out are the shows, some of the biggest shows, talk show hosts on the air. And I'm not going to mention names, but you can probably guess who this might be. I'm not going to mention any names at all. But these are talk shows that have maybe political commentary and other types of commentary. And then they do this, they have these so-called scientists, and I have no idea where these people come from, but they're just, excuse the expression, but it's just being blunt and honest, just spewing garbage. But the next day after I talked about the Tunguska event, of course, they had their little expert on that show to try and tell you that a big ice bolide came into the atmosphere, exploded, and that's what caused this. But it was way high up. So they didn't get that right, that it was close to the ground. And by the way, when I talk about this, it's because the reason the Russian scientists liked my work, one of them, besides explaining what was causing tornadoes on the sun, what was the cause of hurricanes, the true cause of hurricanes and tornadoes on Earth and cyclonic storms, and why do hurricanes move in the westerly direction, etc., and why do they move east when they get farther north. All of these things were coupled with the work that I had done on atmospheric electricity and discovering the work of Tesla, some of the work of Einstein, which even Einstein did not understand. And my work explained a lot of these issues, dealing with general relativity. Okay, so anyway, what I'm saying is that the Russian scientists were very interested in my work because it explained precisely what happened at Tunguska. And I explained this in detail last week. Make sure you go listen to that show. But what I explained was that a comet was coming by Earth. It did not crash into Earth. It didn't get that close to our atmosphere, but the night sky brightened a number of nights before and kept brightening. And then the night of the event was the brightest sky, and this was just the entire sky was lit up. And then the 3 nights afterwards, the night sky faded, this brightness that what was, in the entire night sky, and that was the comet passing by. But what happened was there was an electrical discharge from the comet to planet Earth. And what happened is, now, where does the nuclear explosion come in? Well, what happens is this is the same reaction that Jupiter has in its atmosphere, that Saturn has in its atmosphere, that I learned back in 1979 when I was doing my scientific research at Cornell University. I confirmed, and the Russians confirmed this also, that the fusion is in the atmosphere of the sun. And there's many ways to do this. They had a very interesting experiment, I'll just talk about it right now, that they took an X-ray detector and they scanned. Now imagine here's the sun, and in the center there's a core. And so what they did, here's the sun, and they took their X-ray scanner and they started at the outside of the atmosphere, and they took the signature, the spectrum of the X-ray spectrum from the outside edge of the sun. Then they moved their detector in a little bit, looking at the next little cross-section of the disk, and took the spectrum there, and then subtracted off the spectrum that they got from the outer edge. So what does that leave you with? That leaves you with the spectrum, the X-ray spectrum, that's deeper in the sun. And then you move it over a little bit more, take the spectrum, subtract off the first 2 readings, and now you have the X-ray signature that's down deeper in the sun. And you keep doing this. And what they realized is that when they went deeper and deeper in the sun, it got cooler and cooler. It didn't get hotter and hotter, as you would expect from the core fusion model of the sun, which it's traditional theory that is saying that the core of the sun is the source of fusion, and then they're saying gravity, the pressure of gravity kicks off the reaction, and that is not true. What I discovered was that the fusion at the sun is up in the atmosphere, just like at Jupiter and just like at Saturn. And so those are 2 small lit stars. Jupiter is actually a small red dwarf. It's a companion to our sun, has the exact identical atmosphere, and it has the identical processes going on. Also, when the Voyager spacecraft went by Jupiter, it was reported in the science articles by Brad Smith, the head of the Voyager project, that there was a proton wind coming off of Jupiter, the same as the sun's proton wind. Okay, so anyway, all of this, like I say, is explained in my work, but I'm giving you this introduction because now I'm going to talk about ice in outer space. Very important, because this is a third aspect of the disinformation ploy that is simply could not possibly be correct. Now what they're saying is this ice ball came into the atmosphere and then somehow exploded. Well, first of all, there's a thing that happens with small concentrations of water ice out in outer space. It's called sublimation. Look it up. At around 75 degrees Celsius, negative 75 degrees Celsius, water in vacuum sublimates. And now I'll be talking about we have moons, big moons in the solar system that are have serious amount of ice on their surface. And what happens is it's actually a slight atmosphere and gravity that's holding those together, because there are various forces going on here. But a small object does not have the gravity, and I'm going to talk about this a little bit, dealing with when the planet Pluto. When they got to Pluto, you could see the comet coma around the planet as they approached. You could see it moving, and also around its moon, its Charon, its moon. And then when they got closer, there was literally nitrogen snow coming into the atmosphere. There was nitrogen snow, and you could see it falling. From the spacecraft, you could look into the atmosphere and see the snow building up on the surface of Pluto. Why was it doing that? Because it was Pluto has an atmosphere, which it shouldn't have. If Pluto was this planet just formed 4.5 billion years ago and was sitting out there at the edge of the solar system, there's no reason for it to have any warmth at all. But it was actually snowing nitrogen, hydrogen compounds. Water is a oxygen hydrogen compound, but the ammonias and nitrogen hydrogen compounds were snowing into the surface of Pluto. And that was due to the fact that it had an atmosphere, it had atmospheric pressure, and it had the influx of nitrogen hydrogen compounds from the Kuiper Belt region. And snowing and gravity was what was holding that together. But if you have a small icy object in outer space by itself, not even near the sun, it's not going to maintain that ice because of something called sublimation. Now you can, if you go to the grocery store, let's make this simple for some of the scientists out there, some of the ice ball comet model or dirty snowball comet model scientists. Let's make this simple. Go to the grocery store. Go to the freeze-dried food section and pick up a bag of, let's say, peas. Make it simple, or corn, something they can check out. Okay, buy it and then take it home and look at it. And what happens, a freeze-drying process. In fact, by the way, we can thank the Incas of Peru for this process. What they would do is they would take their potatoes. The Incas had 70 varieties of potatoes, and they would take them up to the mountains and they would store them. And because of the reduced atmosphere, there were serious high mountains, and it would freeze and would get cold, and then literally the freeze-dry process, and they could preserve their potatoes for a very long time. I bet the Irish would have liked that, my ancestors. But at any rate, the freeze-dry process is caused by sublimation. So what happens? You get into a lower pressure atmosphere, which is high in the mountains. You get it cold enough, and what happens is the water sublimates out of the food, thus causing freeze-dried food. Well, the same thing happens in outer space, except outer space is a lot colder and it has a much lower atmospheric pressure. So sublimation works really good in outer space. And so if you could take your food and put it out into outer space, the potatoes or the peas or whatever, and make sure that it stays cold enough, it would sublimate and create freeze-dried food out in outer space. It might be a new business venture for some people. But at any rate, the idea is that you are not going to find a ball of ice, a small ball of ice, a mile across or half a mile across or 600 meters across or whatever they're talking about for this ball of ice that supposedly came into the atmosphere at Tunguska and exploded, And so, even if it did, what would happen? The kinetic energy turning into heat, that could vaporize the water and it could explode, but it's not going to cause fire. It would, if anything, it would put out the fire. But anyway, this is the silliness that goes on in standard science. But after my show last week, they had to put this on, this major radio show, to make sure that you, the public, would not get a real flavor for what's going on out there. And so let me talk about what the Russians found. I'll give you that. Now, this is the inside scoop, and like I say, I worked with these scientists, and they were the scientists who went to Tunguska to understand what happened. The number one thing you have to understand about the Tunguska site is that there was not a trace of anything on the ground. And even if you go by the standard of the dirty snowball comet model, that there should be some kind of material in there with the snow, because it went from the ice ball comet model in 1950 with Fred Whipple to every 10 years it got a little dirtier and a little dirtier until they finally called it the dirty snowball comet model, and still crediting Fred Whipple, bless his soul, deceased. And of course he was doing doing a good job as much as he could. But the problem is they did all of this before the space program came about. But end result is that there's all kinds of problems with the dirty snowball comet model. For example, one, when the coma is developing, the coma actually blocks the radiation from the sun to get to the coma to cause it to create a comet. The Halley's Comet, when the French Giotto spacecraft approached it, I talk about this in one of my books. It's a little nursery rhyme. It's a 3-part nursery rhyme. I call it Fluff, Fluffier, and Fluffiest. You should go read that. But it's actually telling the tale about the European Space Agency going by with the Giotto spacecraft by Halley's Comet, and they have Fred Whipple on camera, live on camera, and they're watching as the frames come in from the spacecraft, taking picture after picture and sending it back to Earth. And they get right down to where they're almost seeing the comet nucleus, and it's a bright white potato-shaped object. And Whipple screams out, he goes, "There's the nucleus! There's the nucleus!" And seconds later, the spacecraft breaks through the last layer of water ice, which was the white part, and sees the blackest object ever recorded in the solar system. The nucleus of Halley's Comet was the blackest object ever seen. And so Giotto spacecraft was going by Halley's Comet. This is like 1986. And they were all shocked and stunned at this. And at the same time, then the magnetometer and the other detectors, the electron detector, all just went off scale. The spacecraft spun out of control, and it took them about another day to recover it. It was a gyro-stabilized spacecraft. But it took them about another day to recover it to the point where they could start getting more data back. But what they thought was a snowball was the blackest object ever recorded in outer space. And this is of all the moons and everything else. Okay, so but let's get back to these little teeny bolide type balls of ice that they're talking about coming in the atmosphere and hitting the Tunguska sites. They're just not going to, unless it formed like the week before, because sublimation is going to cause that even away from the sun. It does not have to get solar energy. There's a slight amount of energy. But over the period of 4.5 billion years, there's not going to be anything like that in outer space. The reason the moons of Jupiter and Euclidus, and there's a number of moons in the solar system that have ice, is because of the gravity, in the same situation as with Pluto, as I was discussing there. Okay, so what did the Russian scientists discover? The Russian scientists did a very thorough analysis of the ground. There was no material of any kind found in the ground. And if some kind of rock came in and disintegrated, I don't care how vaporized that material would have been, it would have deposited on the ground. And there's other cases of this, for example, the iridium layer that they found. They knew it came from outer space because it's not a naturally occurring element on planet Earth. So they knew it was layered from some kind of space event, and that led to the concept of something hitting the Earth and causing the demise of the dinosaurs. So you would have found that. They found nothing, not a trace of anything. They knew that the extent of the explosion was hundreds of times more than the nuclear bomb dropped on Hiroshima. So we have a nuclear event. What is going to cause a nuclear event of that magnitude in the atmosphere? And just the electrical discharge by itself would not do that. It would not have that level of energy because the explosion would have had to have blasted out, and it was detected hundreds of miles away. It blew out windows, and it scorched the trees. It was a very fast explosion, and literally thousands of miles away, the shock wave was still detected. It was heard in Europe. And so this was a major blast. We're talking nuclear blast of some kind. So how could an electrical discharge cause a nuclear explosion in our atmosphere? And the answer is that that's the same process that's working on the sun, in the sun's atmosphere, causing fusion, and in Jupiter's atmosphere and in Saturn's atmosphere. Now, you might start to get a clue as to why they don't want people to understand this. Because all of the nuclear science, and by the way, if you don't remember, my advanced physics degree is in solid state and nuclear physics. So it's something I happen to know a little bit about. And so when I made my discoveries, the theoretical discoveries, etc., it was something, like I say, that I know about, the energy levels and what is required to cause nuclear fusion, etc. And by the way, I've mentioned this before in this show, that the methods they're using to create fusion today, these giant reactors, magnetic bottles, etc., are completely the incorrect way of attacking the problem of developing nuclear fusion. But that's, remember, Tier 2 science. Okay, so let's talk about diamonds. Because I remember I'm going to talk about fire. I've talked about fire. I've talked about ice now. And by the way, let me just continue this thought about ice going out into the Kuiper Belt. And a lot of the planets are forming out there, but the ice is not going to only be water ice because, like I say, you can see it on Pluto. We know this for a fact because of close-up observation. We know that Pluto has nitrogen-hydrogen compounds. It's one of the things that it has. And we know that, for example, Titan, the moon of Saturn, the big moon, also has petroleum products and carbon, hydrogen, and nitrogen-hydrogen compounds in liquid form on its surface. It has liquid oceans. Okay, so we know that these very cold conditions exist out in the solar system. So soon we're going to have some spacecraft actually arriving at Kuiper Belt objects. And it's something, I'll just give you a little history about the discovery of the planets. When the first outer planets were discovered beyond Pluto, there was Sedna, then there was another one, then another one, and all of a sudden there was, once they realized they were there and they started doing concentrated searches out in that Kuiper Belt region, they were discovering thousands of planets. And that is why they had to demote Pluto from being a planet, because then they didn't have to explain why all of a sudden there's thousands of planets. Going from 9 to 9,000 or 1,009 or whatever is a big leap, and the public would just wouldn't buy it. Something else was going on. So to save face, they demoted Pluto from being a planet and said, okay, we only have 8 planets now. All the rest of those other things, well, we won't even count them as planets. And they made a silly little rule. They said that if a planet does not sweep out by gravity, does not sweep out the region of space of its orbit, then it's not a planet. But what's funny is if you took Pluto and put it where Earth is, it would be a planet. And if you took Earth and put it where Pluto is, it wouldn't be a planet. It gets so silly. These astronomers, I mean, what planet are they on? Excuse me, I mean, all I can do is laugh at the silliness that goes on. But they did that because they had to demote Pluto from being a planet, so they didn't have to explain why all of a sudden there's another 1,000 planets out there. Okay, so anyway, that's the story of ice, and there's going to be a lot of compounds out there, the oxygen, nitrogen, hydrogen, carbon, hydrogen related compounds out in that outer region. And you can see that Earth, because we have an iron core, spent a lot of time in the inner solar system during its formation as a comet. And yes, comets, the big comets, become planets. They keep building up and building up. The smaller comets don't have enough gravitational field to maintain the material that's being drawn in by the cometary process, so it blows away, they become neutralized and blow away, and there's actually a scientific name for them, those atoms that are neutralized in molecules, they're called neutrals. And actually you can measure them. If you put a spacecraft there, you see them, and that is actually what tricks astronomers into believing that it's coming from the nucleus, but it's not. Okay, so at any rate, let us move on here to diamonds. Now, as I say, if you're a young, anywhere from grade school to high school, and you're dreaming of adventure and wealth, and this is this is the get-rich-quick scheme of the century, of maybe of the millennium, but it's not really easy either, because nobody has been able to accomplish this yet. But there are asteroids out there and planets, minor planets, that are estimated to have vast amounts of minerals. I'll just say minerals because there's a wide variety, and we really don't have a good understanding of what all of them would be, but they know because of the mass of these objects that they're very dense, and so there's a good deal of metal in them. What I'm going to talk about, however, is something very different. Now, let me preface this by saying that diamonds have been found around other star systems, belts of diamonds, like Saturn's rings. Mainly water, dust particles, and water in Saturn's rings. Well, just like Saturn's rings around other planets and other stars and other star systems are bands of diamonds. And now some of these diamonds to be literally seen from Earth, not physically seen, but they know because of the spectrum that you get that these are diamonds, so carbon in its purest form. And so how do diamonds get into outer space? Well, I'll tell you how this happens. Because let's go back to the laboratory. How would you make a diamond in the laboratory? And this is actually the way diamonds are made in a laboratory. You take a vacuum chamber, you take a block of carbon, pure carbon, and that's the basic atomic structure, the element that is the basis of the diamond crystal. And then you have an electron beam, you accelerate electrons, and you vaporize the carbon, and in that environment, what happens is that the carbon structures form what are known as basically Buckminster Fuller was the inventor of what are known as buckyballs, and that's a crystalline structure. And if you see geodesic domes, for example, that's a rudimentary takeoff on the concept of the geodesic dome, and the structure is based on the architecture of the carbon atom. And of course, they can take different forms. But diamonds, if you build a structure, which happens naturally in this environment, then the diamonds start forming inside because you need very high pressure, and that bucky shell, you might call it, can provide the basis for the crystal to grow and the carbon atoms to build up, and that's the environment that you can basically build a diamond. Now the same process, interestingly enough, will form a different kind of crystalline structure called a snowflake. For a long time they were trying to duplicate the process of making snowflakes. Snowflakes. How do snowflakes form? Well, they're up in the clouds. It's very cold. You have water. But how does a snowflake form? If you look at a snowflake, it has a little dirt, just a minuscule amount of dirt, and then the crystal forms around that. And so basically you have an electric field, you have water, and the electron is part of the discharge up in the cloud. And since the electrons are the primary charge carriers in any plasma discharge, they form the electric current. So you have snowflakes forming in the same manner. Now you can do this, like I say, for a long time they experimented on how to make snowflake crystals in the laboratory, and so it's the same environment. You take a pressure cell, basically an atmospheric pressure cell, and you vaporize water, and you put in a needle which takes the place of the little dust particle, and put an electric field on it, and the snowflake crystals form on the end of the needle. Before that, before they put the electric field on the end of the needle, they would get these strange crystalline structures, but not a snowflake. As soon as you put that electric field there, you get the snowflake. The same with the diamonds. But the diamonds, you don't have that carbon environment except in outer space. Now, why do you have a carbon environment around comets? Well, I talk about this in some of my books. I actually talk about it in the Calculate Primes book, where I'm talking about mathematical structures and mathematical structures that build from smaller mathematical structures. So the experiment then is to take a vacuum chamber, like I say, with carbon, a block of carbon, and an electron beam which is induced into the chamber in a vacuum chamber. Now, how is this equivalent to a comet? Well, a comet is the discharge of the solar capacitor. So the nose side, the sunward side of the comet, has the electron beam, and in outer space you have the carbon, you have free carbon, and so that is the environment, just like in the laboratory, to build diamonds. Now, here coming back down to planet Earth, this is maybe getting a little too far out in outer space for some of you, but when they look at the archaeological digs of the mastodons, like up in Alaska, the mastodons died in a huge catastrophe that was caused by a large passing comet. But the upper side of the mastodons, including their tusks and bone structure, and if there's any flesh left, which there is in some cases because they were well preserved in the permafrost, you see them just raining down. It rained down microdiamonds, and in fact, there's other places in the world where I've discovered microdiamonds, And it's part of my ongoing research with one of the archaeological, was a study that I'm currently undertaking, where there's evidence of microdiamonds hitting a large area of planet Earth. But also the question of where do the microdiamonds come from? Now here again, the silly science coming from Standard Science and from some other communities is that a ice ball comet, which doesn't exist in reality, hit the the Greenland ice sheet, which does exist in reality, but you have water hitting water, and somehow this created microdiamonds. Now, explain to me, please, how water hitting water at high speed creates diamonds. Where's the carbon? Where's the pure carbon? I mean, it's like I say, the third grader wouldn't be fooled by the silly science. But they have to keep going on with this dirty snowball comet idea that comets are somehow ice balls. It's absolutely ludicrous. But anyway, the real source of the diamonds is from the nose side of comets, the sunward side of comets, and that's where they come from in abundance around other star systems. So can you imagine some of the maybe fist-size or basketball-sized diamonds that you can find in outer space? Now this raises a big question, and that question is, well, what about diamonds on Earth? And so the belief is that diamonds are created deep in the Earth and somehow come up, they're vented up when volcanic action occurs, and they're found in certain places on planet Earth. Well, the problem is that for a diamond to form, the concept, this is what the textbook explanation, is that the diamonds form under high pressure deep in the ground. And so the question is, well, how exactly does that work? How can, if you're putting pressure on something as hard as a diamond, then you need something harder than a diamond to put the pressure on it up to a certain point. So how can Earth, that is softer than the diamond, put the pressure on the diamond to form the diamond? Well, and typically that's not how crystals form. Crystals form, if you look at quartz crystals, if you look at, let's see, other crystals I've worked with, molybdenum or tungsten crystals, or you look at other types of crystals, crystalline ice. They typically form by one atom at a time. A snowflake, perfect example of a crystalline structure that is forming one atom at a time, literally. And so the idea that you have something this hard without pressure being applied to it is, it's the way crystals form, and it's a natural process of the atoms forming together in this in a crystalline structure. So if you part of, say, thermodynamics, one of the things we studied in our senior course in thermodynamics was crystalline structures and the formation, the different atomic patterns, etc. In fact, my senior thesis when I was an undergrad was working with Auger electrons, they're called. Auger electrons are using the wave properties of electrons, and we were studying molybdenum and tungsten crystals using Auger spectroscopy. That was my very advanced work as a senior in college. And I worked, in fact, my junior year, the summer after my junior year and my entire senior year on that thesis was very interesting work because we were dealing with low pressure vacuum systems, etc. So the crystalline structure, you can build crystals without high pressure. In fact, it happens all the time. If you look at quartz crystals in the ground, you will find that they form by the minerals building up over long periods of time, and they form these absolutely gorgeous giant crystals. At any rate, I should go get one of my crystals. I think I'll do that. On the side of the desk here. As diamond, the same structural process of forming a crystal without pressure. And here's a little guy. I don't know if you can see that. And once again, a crystalline structure. And here's, by the way, an amorphous type of rock, which is not crystalline. Amorphous being the Greek word for basically meaning no defined shape or form. And there again, here we have another crystalline structure. You can see, I hope, as I turn this around, you can see the crystalline structure. And once again, this did not form under high pressure. And so the idea that these people, it's the problem with standard science. You get these ideas in your head, and I learned that as a little kid. Diamonds form under high pressure, and it makes all the sense in the world that you need high pressure to make something that hard, when in fact it doesn't require high pressure at all. This did not form under high pressure. So why can't a carbon structure with diamonds form with a similar process? But you have to understand what that similar process is, and it takes the conditions I talked about. You need the carbon, you need vaporized carbon, which you're not going to have in the atmosphere. You need it in outer space. You need the electric field with the electron beam. And so where does that electron beam come from? In fact, right here, over there in this picture, this is a diagram of the electric fields and the action around a comet, a small comet. That's from a paper that I wrote called Dynamics of a Small Comet. But the electron beam comes from the sunward side, and that's because electrons have the highest mobility of any of the charge carriers in a discharge, and so therefore the electrons are the primary charge carriers, and you have an electron beam, just like you have in the laboratory where you can create diamonds in the laboratory. Okay, so back to the idea now. This standard idea is that the diamonds are formed deep in the earth with high pressure. Excuse me. And it's not necessary. It's all the crystals I've just shown you formed without any high pressure. And there's a contradiction there too. And I just talked about that. If you go deep down in the ground, the diamond would be the hardest thing around. And so how do you get the high pressure on a diamond from dirt that's softer than the diamond? It doesn't make any sense. It's absolutely ludicrous to think that somehow that's how diamonds form. And then they magically come up these volcanic vents and distribute them in special places in the world. And no, that's not the case at all. Like I say, they have detected belts of diamonds circling other stars. So where do those come from? Well, that's because if you look at, for example, the debris field of a comet, you would find the diamonds in that debris field. And so in any given night, if we're looking at meteor streams, some of those objects coming into the atmosphere and giving a vapor trail would be small microdiamonds. And so some of them maybe fairly large and hitting the ground. I remember a cute scene. I don't know what this movie was from, but the prisoners were there and they were being guarded by these night guards. And they were seeing shooting stars. So one of the prisoners said, "Hey, did you know that every one of those shooting stars is a diamond?" And they started throwing rocks, and the guards, because of their greed, and they wanted to go find the diamonds and become rich, started chasing all over the ground looking for the diamonds that were falling from the meteor streams, and these guys escaped. I don't know what movie this is from. I saw it long ago. It's a very old movie. But anyway, the idea is that it was very interesting, but that's really the case. And so when you see the mastodons just peppered, literally peppered, with microdiamonds on the upper side, not the lower side, on the upper side only. So they died, they fell over, and then they're sprayed with these microdiamonds. Well, where did those microdiamonds come from? It's not because a ball of ice hit the Greenland ice cap. And by the way, the reason they say it hit the Greenland ice cap is because there's no place on planet Earth that is shows the remnants of something hitting that you would find a crater there. So it magically goes away because it hit the ice cap of Greenland. So ice hitting ice makes diamonds? I don't think so. Pretty ludicrous. Okay, so at any rate, I hope this makes a lot of sense, but the thing I want to get back to is the original story of Tunguska. Now, this is such an important event in Earth's history because it tells us exactly all of these different things. It confirms everything I've been talking about, the atmospheric fusion on the Sun, Jupiter, and Saturn, and the fact that that kind of process, if you have a high enough electrical discharge, a large enough electrical discharge, you can kick it off in Earth's atmosphere. Okay, so that's one very important thing. The fact that there was no remnant, there was nothing physical that came into the atmosphere. It was an electrical discharge, and also that talks about the comet being a plasma discharge comet and not hitting Earth and doing damage at a distance, what I call action at a distance, a term that I've used since my original studies, talking about the electrical and magnetic. Now, of course, action at a distance is a term that anybody could possibly use, but the way I was using it was to discuss the electromagnetic effects on planet Earth. In fact, my book, Planet X Comets and Earth Changes, is one of the key aspects of understanding there is not what Newton might have believed about gravitational fields or something like that, but about the electromagnetic fields and the electrical discharges that occur in outer space, what the ancients talk about. When we talk about the mythology of the ancients, we talk about Zeus throwing lightning bolts across the sky and hitting the other planets. This is what the ancients saw, and they chalked it up to mythology. But now there's a physical basis. We understand the physics of how this would happen and how you would see that. In fact, I talked before on this show about the militaries, and this is also in the 1990s. The military sent a satellite up to detect electrical currents in outer space. And one day, due to an alignment that Earth had with Jupiter, we got a blast of electrons, and they didn't know what was going on, so they came out to me and they asked me what would cause this. And the answer is that we got caught up in the no-side electron current of Jupiter. It's discharging the solar capacitor, and Earth connected into that discharge, and you measured it on your satellite. That's exactly what's going on. It's exactly the same electrical discharge that would be cause the formation of diamonds if it were a much bigger discharge, because the comets have a bigger discharge when they are in elliptical orbits, because they're running across the gradient of the electric field. So these are some technical terms, but basically they're in elliptical orbits. They discharge the solar capacitor to a higher degree than objects in circular orbits like Jupiter, Earth, etc. So once again, visit my webpage, and a lot more information there. And also check out the water filter products, the Grow Tower products, something that are just amazing products for food, water, and I'm not going to describe all that here. I believe that this show should be dedicated to science, not advertising. But check it out, and we'll talk to you next week.
This has been Master of Science with host James McCanney. Join us each week as James will delve into historical figures such as Nikola Tesla, Albert Einstein, and the great mathematicians as we explore the history of man, Earth, and our universe as you've never seen it before. Tuesdays, 7 p.m. Eastern, right here on the Bold Brave TV network, powered by B2 Studios.